In the field of astronomy, discoveries often redefine our understanding of the universe. The latest such revelation has arrived in the form of 3I/Atlas, a cosmic visitor from interstellar space that has left scientists and the global scientific community awestruck, intrigued, and perplexed. 3I/Atlas is not the first interstellar object to be detected within our solar system. This title belongs to Oumuamua, an object that arrived in 2017 and made waves in the scientific world due to its unusual shape and rapid movement. The second interstellar visitor, 2I/Borisov, was observed in 2019 and quickly became an object of great interest for its high-speed trajectory and composition. But 3I/Atlas, the third such object to be detected, brings with it a new set of mysteries that are completely altering our understanding of space, celestial bodies, and the physical forces that govern them. A cosmic traveler, discovered on July 1, 2025, by the Atlas Asteroid Terrestrial Impact Last Alert System Observatory in Chile. 3I/Atlas is a comet-like object that has entered our solar system. However, unlike typical comets that are made up of dust, ice, and other elements left over from the early formation of the solar system, this interstellar object challenges expectations at every turn. Initially thought to be just another comet passing through, 3I/Atlas defied standard comet behavior almost immediately. One of the first surprising aspects of 3I/Atlas's journey through space is its incredible speed. Traveling at an astonishing 60 kilometers per second, this object is moving much faster than anything we typically encounter in our solar system. In fact, this speed is so great that it cannot be captured by the sun's gravity. The object's trajectory is hyperbolic, meaning that after it passes through the solar system, it will continue its journey out into interstellar space. Unlike planets, asteroids, or comets that orbit the sun in elliptical orbits, 3I/Atlas is merely passing through, destined to leave the solar system forever. This high velocity is one of the first indicators that 3I/Atlas is not just another ordinary comet. Its speed is unlike any comet previously observed, indicating that it is not subject to the same gravitational constraints as objects that have been part of our solar system for eons. This behavior suggests that the object's origin lies outside the familiar bounds of the solar system, an idea that has ignited many debates among astronomers. A 7 to 10 billion year old mystery, the excitement surrounding 3I/Atlas has only grown with the discovery of the object's age. According to leading experts in astrophysics, the comet is estimated to be between 7 and 10 billion years old, roughly twice as old as our sun. This age alone suggests that 3I/Atlas was formed in a completely different era, long before the solar system even began to take shape. It is a relic from a time when other star systems were forming, and its long journey across the universe could carry valuable insights into the conditions of the universe billions of years ago. The age of 3I/Atlas is also significant in that it opens the door to questions about the potential for life or other forms of civilization elsewhere in the universe. The object's antiquity could provide us with a glimpse into the kinds of stellar environments and physical conditions that could have existed long before the Earth, the Sun, or our solar system even formed. Avi Loeb, a prominent astrophysicist from Harvard University, commented on this profound discovery, stating that the comet's advanced age makes it unlike anything we have ever encountered. Loeb's analysis suggests that this object could be a glimpse into the history of the cosmos, offering us the chance to study a material that has existed far longer than the solar system itself. Loeb's sentiment was echoed by many other scientists, who noted that the comet's unique characteristics demand more than just basic scientific inquiry. They call for a serious reconsideration of our understanding of cosmic history. Whether it be its speed, trajectory, or composition, every feature of 3I/Atlas seems to defy the conventions that scientists have relied upon to study celestial objects within the solar system. An unexpected chemical composition, perhaps the most fascinating aspect of 3I/Atlas, is its chemical makeup, which has confounded scientists. Traditional comets, such as those that come from the Oort cloud or the Kuiper belt, contain a mix of dust, gases, and organic compounds. Their composition gives us valuable insight into the primordial materials that were present in the early solar system. 3I/Atlas, however, is not behaving according to the standard rules of cometary composition. Astronomers have found that the object is emitting intense emissions of nickel, an element that is typically found in combination with iron and other celestial bodies. However, unlike other natural celestial bodies, the nickel found on 3I/Atlas is not accompanied by iron. This is a remarkable discovery because it contradicts everything we know about the behavior of metals in space. In virtually all the comets and meteorites we have studied up to this point, nickel and iron always appear together, forming alloys that scientists are very familiar with. However, the nickel found in 3I/Atlas does not seem to follow this pattern. This unusual behavior has led scientists to wonder whether the nickel is part of an entirely new compound, one that has never been observed in space before. What makes this even more mysterious is the fact that the nickel detected is not free-floating, but rather bound to carbon and oxygen molecules, forming a compound that is only known to occur on Earth through industrial processes like metal refining. In other words, the material found on 3I/Atlas is the type of substance that is typically associated with human-made processes, such as the refinement of metal ores on Earth. This unprecedented discovery has led some scientists to hypothesize that 3I/Atlas could be more than just a natural object. It could be of artificial origin, potentially constructed by some unknown civilization or even a technologically advanced alien race. This theory has opened the floodgates for further speculation and debate. Could 3I/Atlas be a piece of alien technology? Is it possible that it is a relic of a civilization that predates our own by billions of years? While these ideas might sound speculative, the extraordinary chemical composition of 3I/Atlas has made them a topic of serious discussion among some of the world's leading physicists and astronomers. An anti-tail facing the Sun, as if the strange speed and chemical composition of 3I/Atlas weren't enough to excite the scientific community. The object has also been observed to develop a tail that is unlike any other comet in the history of space science. Typically, the tails of comets always point away from the Sun, driven by solar radiation and solar winds. This phenomenon occurs because the Sun's energy causes the gases and dust in a comet's coma to be pushed away, forming a streaming tail that is a hallmark of these icy travelers. However, 3I/Atlas has developed a tail that points directly toward the Sun, which has confounded scientists and led some to refer to it as an anti-tail. This discovery is particularly intriguing because it challenges the basic principles that scientists have used to model comet behavior for centuries. Tiga Egbor, a reporter from The Debrief, describes this anti-tail as more than a curiosity. It's an opportunity to learn about physical processes normally hidden from observation. The fact that 3I/Atlas's tail is behaving in such an unusual manner has prompted scientists to rethink existing models of how comets interact with the Sun. To understand this phenomenon more fully, advanced imaging and spectroscopy have been employed by astronomers, providing unprecedented insight into the structure of the comet's tail. What they found is nothing short of extraordinary. The structures in the comet's tail are unlike anything previously documented in other comets, leaving scientists with more questions than answers. The potential for new scientific discoveries, while there is still much to be learned about 3I/Atlas. Its arrival is already sparking profound discussions